This video will focus on our fifth reaction type, which is combustion reactions. So when you think of combustion reactions, you may think of explosions. People often do, but a combustion reaction actually is just fire. So anytime something is burning, that's a combustion reaction. Combustion reactions can be used to make things explode, but obviously, since you've experienced fires without an explosion, they don't always have to make things explode. When it comes to a combustion reaction, here's your general equation for it. It's very unique from the other four reaction types, and that you look at it right now, there's no like A's and B's and C's because it's very specific. So combustion reaction is always some kind of hydrocarbon, so carbon-hydrogen compound, and the other reactant's always oxygen. So those two components have to exist for the combustion reaction to happen and for it to be a combustion. Products then are always carbon dioxide and water and heat. If you remember back to the first day of reactions, that little triangle means heat, and you must include it as a product for combustion reactions. If that's all combustion reaction were, though, you would be combusting right now because you are a hydrocarbon in the presence of oxygen. So luckily for combustion reactions, there's a little bit more to them in that you need something called the fire triangle to make a combustion reaction happen. So you need the fuel and you need the oxygen. But you also need some kind of spark. Okay? Essentially, everything has what's called an ignition temperature, a temperature at which it can combust. And you are not at your ignition temperature right now, so you will not combust. But with that spark, we can elevate something's temperature to the temperature where it combusts, and then it will. Now, if you've ever heard of carbon monoxide being produced because of a combustion reaction, do you realize there's something called incomplete combustion also? So if there's not enough oxygen present, instead of making carbon dioxide, you'll make carbon monoxide, which is why they say things like open your garage in the wintertime when you have your car on, because you will produce that carbon monoxide because there's not enough oxygen present. So just because it's fun, we'll look at combustion here quick, right? If I take, this is fun. So a lighter, right, has no inherent fire in it. The way we get combustion to occur, so this is just a little combustion machine, is with a spark. So inside a lighter is something called a piezoelectric ignition source, and what happens is when you strike it, it creates a spark. And when the spark is created, we basically put a flammable liquid across it, or a flammable gas across it, and that is why the fire comes out. So when I press the button, I'm essentially compressing that piezoelectric, which is creating that spark, which is then igniting all of the butane as it comes by. So if we light a paper on fire, we see a combustion reaction occurring, lots of light, lots of heat. That hydrocarbon essentially is turning into a gas of carbon dioxide and water. Now, the reason why I have ash still at the end is paper is not just a pure hydrocarbon. It has other minerals and metals in it that are being left behind. So this would be called incomplete combustion because all the materials weren't turned into carbon dioxide and water. Okay. One little thing too about how lighter fluid works. Okay, so I have isopropyl alcohol in this jar, which you have at your home, right? And I'm coating my paper with the isopropyl alcohol. Okay. Now, if you ignite the paper, what's going to ignite here is the isopropyl alcohol. And the problem with this particular demo, you'll see that the paper did not ignite, and that's because there's so much water being produced and so much water already in the isopropyl, the paper is wet now, and the paper is not going to ignite. So when we lit your hands on fire when you were holding those methane bubbles, the reason your hands didn't light on fire, same as this paper right now, is because they were wet and all the water was taking in the heat rather than allowing the paper to get to its ignition temperature. Here are a list of your potential hydrocarbons. Okay, on your test, I won't ask for anything more complicated than these. So on your naming test, you guys had a lot more than this. But on your Reactions test, I'll only do the first 5, so meth, eth, prop, bute, and pent, and only the anes and the alcohols. Okay, so these are the 5 that you, well, I guess 10 that you could potentially see on your test. So let's practice writing a couple of these for you so you see how they work. So the first one's asking for the combustion of pentane. So pentane is C5, okay? And that ane means times 2 plus 2, so 12. And the other reactant for every combustion reaction is oxygen, so I'll need to include that. Every time a combustion reaction happens, I make carbon dioxide and water and a triangle. This reaction type can masquerade itself kind of as a single replacement because I have a compound and an element, so be careful about that. Now, for most people, combustion reactions, that part is the easier part. It's easier than every other reaction type in that it follows one set pattern. So what's hard about combustion is balancing. And we have seen these before, and I did mention briefly in class one time that in order to balance a combustion reaction, you should balance out your carbons first, and then you should balance out your hydrogens, and then the last thing you should try to do is balance out your oxygens. And if you do it in that order, it tends to be pretty easy. So for this reaction, I'm going to balance out my carbons first, and then my hydrogens, which I need a 6 for in order to bring it up to 12. Now, if I look at this, I have 10 oxygens here and 6 oxygens here for a total of 16. I can easily put an 8 in front of that O2 to bring it up to a 16. Okay, so that was pretty straightforward when you do it in that order. Then the burning of methane down here. Methane is CH4. And again, I always need oxygen. It's always going to make carbon dioxide and water and heat. Balancing the same way, carbon first, he's good. Hydrogen next. I need 2 of those to bring them up to a 4. And then 2 plus 2 is 4. So I need 2 O2s to make that work. States of matter-wise, I'll usually give them to you for this side, that these are depending. This will either be a liquid or a gas. But then carbon dioxide is a gas at room temp. Because combustion's hot, you're going to get water out as a gas. And then obviously heat doesn't need any kind of state of matter because it isn't. Okay. One thing I do want to show you that can happen, so let's do C6H14 for a combustion reaction, is why I'm going to show you why sometimes balancing it can be tricky. Okay. So if I do this one, I'm going to bring carbon up to 6, and then my hydrogen needs a 7, and now that's going to be 12 plus 7, which equals 19 for oxygen. There's nothing I can put here for oxygen that brings that up to a 19. So a lot of people go like, now what? Well, luckily it's pretty straightforward. When that happens, come back to the start and double your hydrocarbon. Essentially, you just tried to balance it with 1 hydrocarbon and it didn't work. So now let's do it with 2 instead. What that does is doubles everything I just did. I did have a 6, now it's a 12. I did have a 7, now it's a 14, which means essentially I'm taking all of this and multiplying it by 2 also, which means instead of a 19 right here, I now have a 38. Okay. Can I put something here that brings oxygen up to 38? Absolutely, right? I can put a 19. So that can happen when you're balancing combustion reactions, and that can be tricky. That's really all you need to know about combustion. Go ahead and do the questions and have a nice night.